A rational number is defined as any number that can be written as the quotient of two integers, or when you can divide two integers. In beginning algebra, I like to say that a rational number is really just a fancy term for a fraction. Also, when we talk about rational numbers in higher algebra or algebra 2, we're talking about fractions with letters. So rational number and fractions are two terms that you can put together in your head. So here are some examples. 3/4, 3 divided by 4, -4/11, 8/8, which can be reduced. I wanted to talk about negative numbers. When you write a negative fraction, you can write it with the negative out in front of the fraction, or this would be equal to having the negative sign with the numerator or having the negative sign with the denominator. Those are all three equal expressions. What's not the same is if you have a negative sign on both the top and the bottom. In fact, that would be a negative divided by a negative. That would actually be equal to positive 1/3. The top of a fraction is called the numerator. The bottom of a fraction is called the denominator. The first topic that we'll talk about is reducing fractions. When you reduce a fraction, you are actually turning it into an equivalent form of the same fraction. They're actually the same fraction. One form is just simpler. To do this, you want to find a common divisor that divides out of both the top and the bottom, both the numerator and the denominator. For example, 18/30. The largest number that can divide out of both of those is 6. So I'm going to divide both top and bottom by 6 and come up with the fraction 3/5. 3/5 is the same as 18/30, just simpler. Think of a pie cut into 30 pieces and eating 18 of those pieces. That's the same as a pie cut into 5 pieces and you eat 3 of the pieces. The 6 is called the greatest common factor. It's the largest number that divides out of both top and bottom. If you're reducing a fraction and you don't see the 6 right away, you can also do it in a different way. 18/30. I see that they're both even. I don't see the 6 right away. As long as they're even, you should be able to divide a 2 out of both top and bottom. I always check for that trick first. So 18 divided by 2 is 9. 30 divided by 2 is 15. So 9/15. I see that 9 and 15 both divide by 3. Nine divided by 3 is 3. 15 divided by 3 is 5. Again, I get the same answer, 3/5. If I divide by 6, or if I divide by a 2 and then the 3. Notice the 2 times the 3 would make the 6. When I'm reducing, I always look for 2s, 3s, 5s, and 10s if you can't see the number at first. Another thing to note is that if you're not good with your multiplication and division facts, this is going to be a harder process. You should practice those. 60 divided by 140. I see that both end in 0. So I will divide out a 10, both top and bottom, giving me 6/14. Then I see that they're both even. That means a 2 can divide out of both top and bottom, giving me 3/7. 3 and 7 are relatively prime. No number divides into both of them besides 1. So that is reduced all the way, 3/7. 5/10. You may be able to just look at the fraction and reduce it. For example, I know that 5/10 is equal to 1/2, just by looking. But if you couldn't tell just by looking, again, the common divisor there is 5. I can divide a 5 out of both top and bottom. And I get 1/2. Again, always think pies. If you eat half of the pie, That's the same thing as having 10 pieces and eating 5 of them. 36/4. There are two ways to think about this. If we use the method that we've been using, we can divide both top and bottom by 4. Which gives us -9/1. Anytime you have a 1 in the denominator, it's the same thing as just -9. Another way to think about this would just be to think of it as a division problem. -36 divided by 4 is -9. This is an improper fraction, where the numerator is larger than the denominator. I'm going to treat it the same. I see that they're both even, so I can divide a 2 out of both top and bottom, leaving me with 14/10. I see they're still both even, so I can divide another 2 out of both top and bottom, giving me 7/5. I could also, from the beginning, have divided a 4 out. 28 divided by 4 is 7, 20 divided by 4 is 5. I like in algebra to leave it as an improper fraction like this. You could also change it to a mixed number, 1 2/5. That would be not wrong. A step that we'll do in the next video when we add fractions is we will need to unreduce. That is to turn 2/3 into the equivalent fraction that has a denominator of 12. So again, we're going to take this process and do it backwards. We're going to start with the fraction like 3/5 and multiply to get over to the 18 and multiply the 5 to get over to the 30. That's what we're going to do here. You use the denominator as a clue. 3, how does that get turned into 12? Well, if you times by 4. So since we times by 4 in the denominator, we will times by 4 in the numerator as well, and 8. 2/3 and 8/12 are equivalent fractions. They're the same value. How did the 4 get turned into the 20? By multiplying by 5. So do that in the numerator as well. 1/4 is equal to 5/20. 8 times 7 makes 56. So you want to multiply by 7 in the numerator as well. 35. Again, we will use that in the next video when we add fractions. I talked about it a little on the previous page, but a fraction bar can act just like a division sign. So to change from a fraction to a decimal, simply divide the top number by the bottom number. Most of the time you will have a calculator to do this. So on a calculator, to find the decimal equivalent of 3/8, you just do top divided by bottom. 3 divided by 8 on a calculator. It makes a difference. You can't do 8 divided by 3. Order matters in division. 3 divided by 8 on a calculator is 0.375. To do this same process by hand, again, you're going to take the number 3 and divide it by 8. My decimal place will go straight up. 3 divided by 8 is 0.375. An improper fraction is a fraction where the numerator is larger than the denominator, like 9/2 and 36/3. Beware that if you are changing an improper fraction to a decimal, the number will be larger than 1. So this number, 9/2, and this number, 36/3, should be larger than 1. A fraction that is not improper, 2/9 or 1/4, those should be decimal numbers less than 1. Again, these are calculator problems. Enter into your calculator 2 divided by 9. You get 0.222222222. Your calculator cuts it off after a while, but that 2 actually repeats. Here's how we show repeating. A bar over the 2. 0.2 repeating. 9 halves. 9 divided by 2 is 4.5. Again, a number larger than 1. 36 thirds. 36 divided by 3, 12. A whole number. 1/4. I know that one as 0.25. A quarter is 25 cents. At the beginning of this video, we talked about the term rationals. When we refer to rationals in mathematics, a lot of times we are talking about fractions. The technical definition of a rational number is any number that can be shown as a fraction. And you'll see that sometimes fractions look different. 36 thirds, that's the same as a whole number. These numbers here were the same as decimals that did not repeat, that just stopped. And then we had a decimal number that repeated. So when I think of rationals, I think of whole numbers, decimals that stop, and decimals that repeat. So what is the opposite of a rational number? Irrational. So what does this mean? What's left? Well, any number that, when written as a decimal, doesn't stop and doesn't repeat. For example, the square root of 2 is an irrational number. If you type the square root of 2 into your calculator, you'll get this. And it will keep going on and on and on with no repeating pattern. Pi is another example. We use pi a lot in geometry. It keeps going on and on forever with no pattern. That's an irrational number.